I'm Valon Shabani. I'm a front-end developer at OpenResearch, and I picked the topic today for the same reason. I have a beef kind of with these backend guys, and they are talking about microservice for a long time, and we wanted to show them, okay, we can also do that. It's not some fancy stuff, so we can do that also on front end. Okay, so what is actually the problem and why this topic popped up? When we have a team of 5 developers, nothing's complicated, we can have one app, everybody's synchronized, that's not a big problem. When start growing, and that's what everybody wants, to start growing, but you start seeing problems and so on. And when you have, let's say, 15 developers, then it starts to get messy. It's not maybe that it's a big problem, but you start seeing problems there. But if you are like 50 developers, it's a complete chaos. So it's not an option to work normally, to have like everybody on the same project and just to work as usual, a small project. So we have these daily realities, which is the build time will increase a lot. We have single point of failure because we have one team of 50 people, everybody working on the same exact code. And of course, merge conflicts and deployment pressure, because every time we're building the same chunk of app that is responsible for the whole logic. So as the team grows and we start seeing impacts of this team grow, the most things that you can right away notice is that feature delivery will increase. And even with the same feature, let's say you have whatever single form that you will do, if you have a really large application code base, doing that, it's much more complicated because you need to consider a lot of context through all the application and so on. So originally, also the feature delivery will be increased. Of course, teams will be blocking teams because you need to wait for one page to be able to continue with another one, and you always have features that are blocking other features. Of course, also deployment risk, because as I said, everybody is deploying something, everybody is working on the same application, but one failure can fail the whole app, which is not what we really want. And of course, the least important thing, developer happiness. Of course, if we have a large code base, a lot of people working on it, we won't be so happy around it. So what's the solution that I'm going to try to present today, at least give you an initial idea, is what if we don't have this one big app? Of course, 2.5 megabytes is not a big app, but this is just a short demo I've done here. But what if we can chunk this and separate this into separate teams and have each team being responsible for its microfrontend, and have a shell that loads these microfrontends at runtime. So what's the key benefits for doing that? It's first, we have team independence. Now we can split the big project into, let's say, 5-people team, and now they have it much more simple to work on the project. It's a clean environment. You don't have to think of the big picture and so on. You only need to focus on one specific thing. Is independent deployment, which is one of the most important things. If you're working on one microfrontend, you can do 50 deployments a week, and that won't be any problem, and nobody from other teams will really care about it. Technology flexibility is also something that it's a good thing with module federation, because now it's possible that you have one application, but inside it you can have multiple microfrontends that basically don't have to be all Angular. So we can have one big app, one page can be Angular, one page can be Vue.js, one page can be React. And this is totally doable and easily done nowadays. And of course, fault isolation. Now if something goes wrong, if we have this big app, it's a bit problematic to see, okay, whose fault was this? But if you have these separated teams, it's so easy to narrow down the problem and to find the real issue. So just a bit of history to go back. This was kind of possible even before, but let's say in 2000s we had iframes, and iframes were perfect isolation, but the UX, as Daniel would say, it was terrible, so it was not a good solution. Then later on, in 2010, we had these NPM packages, which was really cool. But the thing with NPM packages is that, let's say you have one shell app, and every microfrontend is an NPM package. Always you need to download these packages into your shell, build the shell, and deploy. So if one of the packages changes, you need to do the same process. Download that package, build the shell, redeploy again, which is not what we want. And we have web components, which was a really cool thing when they popped up, and basically they were all happy about it, to say so, because they were standard based and you could do on all frameworks. It was the same syntax, but then it gets complicated because the syntax is very complicated. They are not, for example, from Internet Explorer, then they were not supported at all. And of course, as the application grows, that code is not good to see, and also it's not developer friendly, and nobody wants to work that way anymore. So the breakthrough and the important thing that happened in 2020 is from Zach Jackson, which is basically a Webpack employee, which he suggested, okay, until now we needed to build first everything and then deploy. He said, okay, but why it's not possible to load modules at runtime application? Why it's not possible that I have one shell and I put it on the software, and if he needs one module, he can download it. If he doesn't need it, he doesn't need to download it. So good enough, the C-level said, okay, you can go for it, you can implement it, and he brought us the first feature on Webpack 5, which actually allowed us to do module federation. So before, as I said, if you needed one shared package, you need to do import, shared package, and of course this has to be beforehand, then build and deploy. But now, after module federation, is that now you can dynamically run code that is not at build time. So you can load at runtime whatever module that you need. So what does that mean? If I can have an analogy, it's like code carpooling. So instead of having 3 applications of 2 megabytes each, having Angular, some shared utilities and functions, I can decide to put everything that's common and shared in a shared layer. And then, let's say we have a store and we have product store and cart. Both of them can hold only specific things that are only relevant to this microfrontend, and everything that both use can be put on the shared layer here. And why is this good? Because now we can have shared dependencies, we have a faster loading, because now the shell, the initial loading time, is much more faster because we have a smaller bundle size, and while navigating conditionally and so on, we load the other modules. And of course, the most important part for this reason is the independent deployment, which I will get back later. So to give you, to not like be everything just like, this is a Webpack config. So for anybody context, if you don't know what Webpack is just basically a bundler. What it does is, let's say, for Angular, it just translates every TypeScript file and other file into JavaScript executable file. And this here is basically a plugin that I'm using for Angular. It was done from Angular architects. What this plugin does is exactly just wraps the Webpack so that we don't have to be experts on Webpack, each one of us. But now we can easily, with 2 commands, add a micro app and the configuration will be there. But even that it's easy like that to add it, I would like to show you how the configuration looks like and what it means. So for example, here I have the configuration of the shell. So the shell, the name of course, it's you know it, but here is the important part. We define what remotes this shell can load. Here I have 2 remotes for this demo example. One is products page, which, as you can notice, it's running on a local server with a different port. And cart is also on another port. So we have a shell that's running on 4200, a different port, and also it loads 2 other micro apps that are running on completely different servers. So, and also at the bottom here we have the shared layer. Here we define everything that is common to each one of these micro apps, and everybody should use it or must use it. I will explain what the details tell you. Okay, also singleton true. This is just important to mention because all the libraries that do have a shared state. Like, for example, Angular needs a shared state. We need always to have just one instance of that package running on our app. And this allows that. So for all, the thing that you need to remember is that if your package or library needs a shared state, then you need to put it as singleton true, and because it needs to have only one instance in order for that shared state to work. I showed you the shell configuration. Now what about the micro apps? How do you configure the micro apps so that they can load into the shell? This is how the configuration look for the products page. And this product page is a Webpack based builder. So the builder for this page is Webpack. I need you to remember this. And you can see the structure pretty straightforward. You define the name of the micro app, which is products. You have this file name, which is remote entry.js. And basically, this is the only entry point that the shell will load. Everything else, it's dependent on the micro app. They don't need to care about that. And also here, I'm telling the Webpack what I'm exposing. So if you have a products page, in this case, I decided to expose the app routes, which basically allows you to have the all inner functionality of this products page. And shared, as I said, you put all the shared items. Like, for example, we have put the Angular core and common into the shared layer. And you can see on the shell, the routes are just Angular, normal Angular routes. When a user goes to the products, it lazy loads a module, which is the products module. And yeah, for the same reason, as I said, the products page is running on a completely different server. But for the demo purposes, I made one service which is being shared between these two micro apps. Basically, this service is living on the shell host, and each products and carts are injecting into it. And whenever a user clicks add one product to the cart, it calls this service. And then since the cart is also listening to that, it will update the cart state. This is not production suggestion. So you need to understand when you decide to use microfrontends, you should avoid having shared things between micro apps as much as you can, because then you lose the logic of why having micro apps. So the only thing you need to share and you must share is the authentication authorization part. So you authenticate the user and you authorize it for specific things he can do. The rest should live on the API state level. So the backend is still connected, everything is there. So you communicate with the backend, you do the action on the backend, and whatever you're using, either server-sent events or WebSockets, will update the cart or whatever. But for demo purposes, I've just made this service available so that we can see the communication. So as I said, when the shell loads the products micro app, what happens is we've loaded only one entry point. We told them the door, and now inside we have these all products, books, electronics routes, which are normal Angular routes here, and basically they work just as a normal Angular app. So the shell doesn't need to know about the internal things of the micro app. And you still have this feeling of single page application. Even that you're loading micro apps and so on, you still have the feeling that everything is one single app. But the dilemma started in 2022. Webpack, this feature was great and it was very welcome from everyone in the community, but Webpack is getting slower and slower and slower. And the reason for that is because Webpack is built on JavaScript. JavaScript needs to be translated to Node.js and Node.js to a lower level and then to the machine language. But ES build, which basically Vite is built on top of it, is using directly Go language, and that's a very lower language than JavaScript, so the build time is much more faster. So now a lot of companies are willing and wanting to move to Vite as a compiler. It basically does the same thing like the Webpack, but this feature was very locked into only Webpack. So in 2022, now we have a new thing popping up, and that is called native federation. What native federation allowed us is that we can still do microfrontends and module federation, But we do it on a bit different way because now this supports every bundler. Now you don't have to be locked into Webpack. You can just use any configuration. You can use a Webpack configuration, ESBuild configuration, Vite, or something that will be in the future, because basically ESBuild is based on the standards of ESM. So now, for example, one big difference that you can already see is before, if you would like to load the module with Webpack, this is how you would write it. And this is pretty ugly syntax, not for us front-end developers. It's not very common to see that. And this is like standard. You can see it everywhere. There's one because this is ESM. And now you have await import, you have export, basically on all different frameworks. It's the same thing. That's why with native federation, now we can do micro apps no matter what bundler we have on the back. And this is very important. So if we look at the difference on the configuration, it's almost identical. In fact, in this case, they are, for the things we are using, are identical at all. You don't see any difference. Just the file name here is federation.config.js, and there is webpack.config.js. So, as I told you, right now on the demo that I will show you, I have a shell, which is Angular 18, and it's running on one port. And then I have two different apps that are both cart is on a native ESBuild, and products is Webpack. Why is this important? This is important especially for big companies that were using Webpack and so on, and now they want to transition to Vite and so on, and they use micro apps. This demo will showcase you a very cool example that allows you to do this incrementally. So now if you have, let's say, 15 micro apps, they are all Webpack, you don't have to switch all at once. You can have a shell that is possible to load both, no matter if you have a module federation or a native federation, and then you can go micro app by micro app and migrating them to ESBuild. So this is a very solid solution that will help bigger projects gradually translate their code into like ESBuild and not do everything at once and risk everything. So these are the real case scenarios and success stories from around the world. SAP, everybody probably knows them. They have more than 100 micro frontends, and they have more than 50 teams working on those. And strange enough or not, they do 200 deployments a day, which is pretty huge. And that's only possible because these apps are so small and so manageable that you can easily do a lot of deployments and you don't have to be afraid that you will break everything on your business. So this is a decision graph. If you ever come up to a question, do I need to use micro frontends? You can easily decide it. If you have less than 5 developers, do not even think about it. If you have 5 to 15, then maybe, but first you should use monorepo, something like NX or something else, but that should cover mostly everything. And if you have more than 15 developers, then another question should come up. Do you need independent deployment or not? If you need independent deployment, you should go with micro frontends and federation. If not, you can still manage it, I think, perfectly. It's my opinion with a single code based like on monorepo NX. So this is the golden rule I want you to remember. Use micro frontends for organizational solutions and so on, not for tech-based solutions. It's not about technology here. It's more about structuring the organization. This is a very head-to-head comparison between module federation and native federation. Webpack is, for one thing, very good because it's more mature. We have a lot of plugins for it out of the box that helps us do complicated stuff. It's very large ecosystem, but it's locked to Webpack, and as I said, we have slower builds. So now that's the downfall for it. And of course, key concept is Webpack specific, doesn't work anywhere else because we have this Webpack required for importing modules. But with native federation, it works with any bundler. We have faster builds. It's future-proof. That's where the future is heading. And of course, it's a smaller ecosystem, but that doesn't mean that it is a problem because this is production level ready still. So which one to choose? Choose module federation if you have an existing Webpack setup. If you need more mature, battle-tested solution, and there's something specific that you still cannot find on the native federation, and you want extensive documentation, because as I said, the community is bigger, and that's why the content about this topic is much more bigger, and you can find a lot of things easier. Choose native federation if you want bundler freedom, so you don't want to be locked up to Webpack or any other bundler. You are starting, so if you're starting a new project, my recommendation is that you always start with ESBuild as a bundler, and of course, if you need federation, then you can also use native federation. As I said, both are production ready. Of course, there are some problems when you start using micro apps, and the most important ones that I wanted to mention here is the first one is version mismatches. So now it's recommended that you have all your micro apps on the same version. For example, if all our setup is Angular, we need to have Angular on the same level. Otherwise, if we have this configuration, even that we can say here strict version false, but that's not recommended for Angular specifically. And now one shell uses Angular 18, but one micro frontend uses Angular 17. We will have runtime error. So what's the thing that we can do for that is, of course, have teams coordinating and doing at least every 6 months a synchronized upgrade of the tech that we are using. So the companies are doing that. And oversharing is the other problem. Oversharing is, for example, if I do this on my Webpack configuration, share all, I'm telling Webpack basically go and check what's on the package JSON, and everything that's there, share for all my micro apps, which is not optimal because we kind of lose the logic of why doing micro apps. So that's why we need to specifically tell what things we want to be shared there. And that's why it's better that you tell, okay, I want to share Angular core, I want to share Angular common, RxJS, and some other libraries that I'm doing, because when loading, now shell can say, okay, I have these 3 packages that are loaded, and I can easily load the module. But if I have the whole package JSON loaded, then he needs to negotiate all packages if they are compatible and so on. So it's a much more slower process. So this is the recommended way to do. Share only specific packages. And of course, that's for the user experience as well. I could not ignore this since Daniel was here. When you try to load, let's say, the products page, and now you have a problem on the micro app products, you will see a very ugly, unresponsive page. You need to have a downfall strategy that, okay, what should the user be presented with if we fail to load a specific micro app? As I said, this is just some rough example. If you have a large code base and it takes 45 seconds to do that, if you split it, it will be, let's say, 8 seconds for build, which is huge, like faster, much more faster. And of course, we have the deployment risk. As I said, on monolithic front-end application, you risk of breaking even if you change a small thing on the app. But here, you don't have that risk. You can break one part of that big app, but not like everything with a single line. And of course, the bundle size now is much more slower because we don't load everything we want at the beginning, but we just load what we need initially, and then when user navigates and goes deeper into our app, then we load what needs to be loaded. So that's why the initial loading time is much more faster. So what the key lessons that we need to take from this is if we need to have a successful micro app strategy and structure in place, we need to define some rules. So the first thing is we need to have a very clear of team boundaries. Each team should be responsible only for one specific micro app, and there should be boundaries that they cannot cross and they cannot do, because otherwise we can create more problems that we are solving. Communication. This is, as I said, avoid shared state whenever possible. If you need to have a shared state, you need to document the contracts that you are using to communicate on that shared state, and that's why my recommendation is only authentication authorization. In my view, most of apps is required to be shared. The rest can be just API shared. So, of course, deployment strategy, you need to version your microfrontends, and you have to have a rollback plan in place. So if one microfrontend fails and breaks, we need to have a fallback plan that we load an older version of it and everything keeps moving. Monitoring, you need to track everything so that also you see where you're lacking of good optimization. And of course, this is recommended to do even beforehand, because it's not like a good idea just someday to come at the office, okay, this is one cool topic, module federation, microfrontends, and we can do that, because you need to have a deep insight of your metrics inside your company to really see if it matters and if it's worth of adding this complexity to your setup. Developer experience, as I said, if you have this split up, now everybody is much more happy. Instead of having 50 colleagues, they have now just 4, 3, and everything is much more simpler. We don't have this overload of having the bigger context for everything, so our life is easier that way. And I said, the golden rule, microfrontends solve people problems, not technical ones. So I don't want you to remember to forget this. Sorry. Yeah. And yeah, more and more companies are actually adapting to this. There's very cool tooling that are emerging from it. Like I said, for example, Angular architects have done these 2 great plugins that if you are working with Angular, it's really out-of-the-box configuration, which is basically no-brainer to do that. But for sure, native federation and ES-build looks like the future. So if you're using Webpack, you need to start thinking how you can move to ES-build. If you start living, I mean, if you plan being a company for long enough. Remember, okay. I need you to remember these 5 points. If you want to remember something about micro apps, it solves organizational problems. It's runtime code sharing, so not build time, but runtime code sharing. It's bundler freedom for native federation. And of course, if you are trying to move from Webpack to something like ES-build, please do it incrementally and do it step by step. So move one micro app at once and not like everything in one take. And of course, measure everything so that you have a good overview of what you're doing, makes sense, and everything. Okay, everyone that's here on the emails will receive also the demo examples and so on, but also you can find it on my GitHub if you want to download it and play around with it and break it and see like what works, what not. Maybe some code is generated from AI, but you don't have to mind about that. So. And yeah, if you want to continue the journey about diving deep into this, you want to maybe take a picture of this or you could search, but these are some of the best sources that I could come up with and present to you. If you want to learn deeper on this topic, I think if you are Angular developer, for sure Angular architects are the way to go because they have so much material on this. But of course, also Zach Jackson, as I said, was the founder of the first module federation on Webpack 5. But also you have these cool communities. So yeah, if you want to go deeper, no, I'm not done, so I'm not saying thank you. I will show you just like a demo that I have prepared. But I think I need to remove this first. Okay. Okay, so here, as you can see, I have this app that I was using this example through all the page. I don't know if it's visible enough. Maybe I can increase it a bit like this. So here, I have the products page. As I told you, this is Webpack based. This is a micro app. It's completely separate. It's running on a different server. But we have also the cart, which is ES-built and Vite based. It's on completely different local server. And you can see that you cannot notice that this is like separated apps. You kind of have still the feeling that this is a single page application and everything looks similar. And to do that, of course, Daniel will say you need to use design tokens. So you need to have some contracts that the design should look the same, the colors should look the same, the padding should look the same, and so on. But the things I want to point out is that even that we are having 3 servers running now, you cannot feel that you don't have one application running here. And as I told you, I have that shared service that basically allows also me to add a card to service. And even that this is a completely different application, it receives directly the products that are added to the card. And yeah, the same works vice versa. So if I remove it, it should update the local state. If it would have been something here, then we would see that, okay, this product is removed from the cart. And if I just show you something really cool. So here, I've just some routes that I commented out. You can see the ones at the right. So now I have here one React app that I can load. This React app is uploaded somewhere on some server. It's not even on my local machine. I just have the entry point for it, and I can load it. You see, there's it uses this specific version, but it's an Angular, and it uses module federation. I have here another Angular app. This is an Azure server running, and it's basically, we were using an Angular 12 version, but this is completely being loaded from a remote server. And the same also as Svelte, or whatever that's pronounced. So basically, this is another micro app that this is on some server. It's not even on my local machine. I just have the link to this micro app, and I can load it inside my page, and you won't notice that it's not on my code here. So, and if you just also interested to see a bit the code, so here on the source is the shell, and on the projects you can see I have two completely different Angular apps. Each one of them have their routes, their internal configuration, and so on. So it's just like a small Angular app, but it's on module federation, so Webpack, and we have this other one which is a native federation, another Angular app which is basically the same, but on our demo you cannot notice it that this is not a single page application. So as I told you, if you want to take a look at this code, is for one reason it's very cool, because it allows the shell to load even Webpack or ESBuild, which is a really cool thing, and as I said, allows you to incrementally move to ESBuild and not just have that pain to all at once move you. So thank you, everyone. This was my topic. I hope you understood at least something, and I was not like overcomplicating everything.